Ladies and gentlemen, this screencast will cover solving systems of inequalities by graphing. We've solved systems of equations by graphing and by elimination and by substitution. And we've found when doing that that we can have systems of equations that have one answer or no answers or infinite answers or solutions. So consider as well that a solution to a system of equations is an ordered pair. So when we get x and y, we're getting one solution, one combination of x and y that satisfies the equation. When dealing with systems of inequalities, the difference is that we don't have equal signs. We have now greater than, less than, greater than or equal to, or less than or equal to signs. And we have graphical solutions that look like what you see here on the screen. Here are the steps. I'm not going to spend a lot of time on these. I'm going to show you these. I will highlight a couple of things. The inequality does have to be in slope-intercept form. The line is solid if it's a less than or equal to or a greater than or equal to sign, and the line is dashed, indicating that the points on the line are not included if it's a less than sign or a greater than sign. So let's go ahead and try the rest of these. You'll see this same list of steps at the end, and it's posted on Canvas. So if we look at this system of inequalities, these two inequalities, this is not a system. These are just two separate inequalities graphed side by side. So this is y is greater than 3x. In this case, you'll notice that all of the values that are in pink satisfy this inequality, and the dotted line indicates that the values along that line do not satisfy the inequality. Over here on the right, we have y is greater than or equal to 3x. We have a solid line indicating that the points on that line do satisfy the inequality. So that's the difference. It's a solid line when there's an equal to expression along with the inequality. All right, let's try these two inequalities. First, let's check them to see if they're in the slope-intercept form. The top one certainly is. Y is by itself on this side, and we can see that we have a slope of -3 and a y-intercept of 1. The one beneath it, though, however, is not in the correct format. So we simply need to subtract 3 from both sides so that y will be by itself on one side of the inequality sign. So now this is the equation that the inequality we can deal with. We won't be coming back to the original one. We'll be using this one and this one. So let's go ahead and start with the one on the top. From it, we know that we have a y-intercept of +1 and a slope of -3. So we're going to plot the y-intercept of +1. Then we're going to show that we have a slope of -3 because we move down 3 and over 1, down 3 over 1, down 3 and over 1. So that gives us our negatively sloped line, a line that drops from left to right. So we next put in our line through all of those points. Be sure when you graph these that you graph the line all the way off of the grid. That's absolutely critical. So I didn't just draw my line between the points that I plotted. I went ahead and put arrows on each end, and I plotted the line all the way from one end of the graph grid to the other end of the graph grid. That's critical on these. Next, we need to decide which side of this line is the side we need to shade in. Which set of solutions, the left side of the line or the right side of the line, which side of the solutions makes that inequality true? So the thing we just need to do is test a point. So we need to select an easy point, however, a point that is not on the line, and test that to see if it satisfies the inequality. These are some examples of some of the points that you could test. You will find that I always test the point 0, 0 if I can. The only time I wouldn't choose the point 0, 0 would be if 0, 0 was actually on the line. So let's go ahead and try that. So I have my points x and y equal to 0 and 0. So I drop those into my equation, and I find that I have x is less than or equal, 0 is less than or equal to 1. That's true. 0 is less than or equal to 1. So that means that this point is valid for my inequality in the pink box. So since that point is valid, then that means that I will shade the side of the line that includes the point that I tested. So here's the way this should look. I'm going to shade that side of the line. Now we'll do the other equation. We have rearranged it into the slope-intercept form, and we know what the y-intercept and the slope will be. So with a y-intercept of -3, we will plot the point 0, -3, and then we will use the slope information to recognize that we're going to go down 1 and over 3. We'll go down 1 because it's a negative slope. So down 1 and over 3, down 1 and over 3 gives me this second point, and I put my line in between those 2 points. Notice that this is a dotted line, not a solid line, because the inequality is simply a less than rather than a less than or equal to. So we want to communicate that the points along this line do not satisfy that inequality. The next thing we're going to do is go ahead and plot and test some points. So I certainly do prefer testing the point 0, 0, so I'm going to do that again. So if I drop 0 in here and I drop 0 in for the x value, then I'll find that -1/3 times x is 0, and 0 minus 3 is -3. The statement 0 is less than -3 is false. Since that is not true, then I know that this point 0, 0 does not satisfy my inequality. Since it does not satisfy the inequality, then that means this point is not on the correct side of the line, so I need to shade the other side. So this is what this should look like. I've shaded the side that does not include the point 0, 0, since I ruled it out with my point test. So this is a little bit cleaner version of this graph. It's the same thing. But notice that all of the values that are here in this portion of this graph that look purple, those are all values of x and y that are solutions to the system of inequalities. So for every x and y coordinate that is in this purple area, that's a solution to the inequality. So here are a few that we can just identify simply by reading them off the graph. So the point -4, -2 will satisfy both inequalities. The point -3, -4 will satisfy both. The point -1, -5, and the point +1, -4. All of those points, as well as many others, will satisfy both inequalities. There will be a situation in on your homework, you will need to look at a graph like this and extract points that satisfy the inequalities. So that's why we're practicing that a little bit. Let's look at another set of inequalities. So in this case, we have one solid line here, indicating that this is going to be, the values on this line are included in that inequality, and everything that's less than it is below. Then we have another line that's much steeper and has a positive slope. However, this one does not include the values on that line because it's a dashed line. There are several points that are circled. So this point would be the point +1, 0. This is a little bit off, but this would be the point +1, -2. So look through this and tell me which of the points do you think are solutions to the system of inequalities. These are the equations. And hopefully you chose those points that were in this shaded area that was common to both of the inequalities. Let's try it again. Here's another set of inequalities. So I have one line right here and everything's shaded above in green. Then this is a dashed line. Then this is a solid line and everything below it is shaded in kind of a lavender. So this common area turned out to be kind of gray. So with that in mind, let's think about which of these points are solutions to the system of inequalities. There are the equations. Hopefully those are the ones you chose. Let's look back really quickly and discuss why this point would not be. Notice that this is a solid line. So it indicates that the point that is along that solid line would be included in this inequality. However, this is only a greater than sign. So the point right here, corresponding with the green shading, would not be included. So that's why this point is excluded, even though it appears that it might work. It's the green function, the y is greater than negative x plus 2 function. It does not include that point. So these are our solutions over here in the gray section. All right, here's another system. Think for a minute about which of these you think are solutions to this system of inequalities. Hopefully you chose these two because they are in the area that is shaded both gray and lavender. It comes out kind of that deep purple. Then here are more points that are solutions to this system of inequalities. Some are solutions, some are not. Look at that and see which ones you think we should keep. Hopefully you agree with these points. This point right here, if we took the point positive 15 comma negative 1, so if x was positive 15 and y was negative 4, then that should satisfy both equations. Notice that this is a solid line here, so that's the reason why this one would work. I caution you against using points if you're asked to identify points. Don't grab a point that's on the line. Grab points that are safely inside. But if you should have kind of an extension question in some situation about how to handle these borders, then you've got a little bit of information about how to interpret them. You will on your test need to identify points within the shared area that are solutions to both inequalities. So be sure and just choose the points that are safer on the inside and choose points where you can reasonably come up with the coordinates of that point. For example, this point right here would be a positive 9 as the x value and a negative 3 as the y value. All right, thank you. Here are the basic steps. This will be posted on Canvas as well.